Hi everyone, this is me Jyoti. Now let us start with the lesson that is operational amplifier. So what is an op-amp? So op-amp is an operational amplifier is a DC coupled high gain electronic voltage amplifier with a differential input and usually a single ended output, and it's a very low cost integrated circuit, that is IC. It mainly consisting of simple things. Those are the transistors, resistors and the capacitors, and it's able to amplify a signal due to an external power supply, and the name derives from its use to perform operations on a signal. It means it will do the operations like addition, subtraction, integration and the differentiator. Okay, so these are the applications of the op-amp. It will act as a simple amplifiers. It means it will used in the communication purposes. Okay, so summers, comparators, integrators, differentiators and analog to digital converters. So this is a circuit symbol and the pin identifications. Mainly it will consisting of 8 pins, but the 8th pin is it have a no connection, so that they are not mentioned here. So the pin number 2 started with the pin number 2. The pin number 2 is a inverting input. 3 is a non-inverting input. This pin configuration is very important because in the lab you have to connect the voltages, and you need to connect the voltages, and you need to connect you need to make the pin as a grounded. So for that you need to know the pin, which one is inverting or which one is non-inverting. So give an attention here. So next, sixth one is an output, and the seventh one is a plus voltage supply, that is a VCC, and the fourth one is minus voltage supply, that is a VEE, and one and a fire offset null. So this is a really look like, it's a, as I told, it's a 8 pin IC. So now it's a inverting amplifier. So here it consisting of an op-amp. Okay, so and here that the inverting terminal, they are taken the two circuits. One is they are supply the power voltage, that is V in, and another circuit is gone to the output. Okay, so here is a one word will come, that is a feedback. Because of they are connected to the inverting terminal, it is called as a negative feedback. The feedback word is means the small amount of signal is feeding from output to the input, because it will help to correct the signals or correct the errors. Okay, so here in the inverting amplifier, they are connecting the output to the input, that is mainly to the inverting amplifier, and it is called as inverting amplifier because they are supplying the voltage to the inverting terminal. In the inverting amplifier, it consisting of only one input is applied, and that is to the inverting input terminal. The non-inverting input terminal is grounded, since the V1 is equals to 0 volt and V2 is equals to V in. So at the open feedback, let us consider it's an open loop, means there is no connection between the input and the output. Okay, that time the gain of the inverting amplifier is minus of V out divided by V in. Okay, I will repeat it. It's a gain of the open loop inverting amplifier is equals to minus V naught divided by V in. Simple. So if I connected the feedback, that's with help of a resistance, that is a feedback resistance. I'm connecting the output to the input. Now with the feedback, the gain of the inverting amplifier is a minus RF divided by R. Now it's non-inverting amplifier. It's the same as the inverting, but one difference is here the supply of the voltage is to the non-inverting and the inverting terminal is grounded. Simple. Okay. In the case of open loop, there is no connection from input to the output. Okay. So at that time the gain is A is equals to V out divided by V in. V in. Simple. But with the feedback, the output, the gain, okay, the gain of the non-inverting amplifier with the feedback, that is equal to V out divided by V in is equal to 1 plus RF divided by R, whereas this RF is a feedback resistance. Okay, so we can say it as a V1 is equals to V in and the V2 is equal to 0 volt. At mathematical level we can take it as line. So next one is a summing amplifier. So in the case of a summing amplifier, so as a name implies, the output is equal to sum of the inputs. Here we can supply the different values of the in voltages, like see V1, V2, V3. Here I am considering the three different voltages, and those all are connected to the inverting terminal. And look at the figure once again. It is a feedback. Here the circuit is feedback. So the output, the V out should be equal to the negative of the sum of the voltages which are supplied at the input terminal. And here look at the formula at the end, that is a V out is equal to minus of V1 plus V2 plus V3. This negative sign indicating that it is a negative feedback, because all the variable signals or voltages which all are connected to the inverting amplifier inverting terminal, for that they are negative sign. If we can connect it to the non-inverting terminal also, that time the formula will become V naught equal to sum of voltages, that is V1 plus V2 plus V3. Now there is no negative sign, so it is a difference circuit. So difference circuit means it will give the difference of the voltages. See the formula, that is a V out is equal to the V2 minus V1. V2 minus V1 is nothing but the voltages which are appear across the inverting and the non-inverting terminal. Integrating circuit. A circuit in which the output voltage waveform is the integral of the input voltage waveform is the integrator or the integration amplifier. It means, so the output is a form of a integrated of the input. It means you can supply any voltages, but output should be a integrated form of the input. It's called as a integrator. Okay, so we can check it. We can check that is it an amplifier as an integrator or not by if we supply the input as a sine wave. If we supply the input as a sine wave, the output should be cosine. Means the integrated of the sine is cosine. So if we supply the square wave at the input, now the output at the output level we can get the triangular wave. It means the integrated form of a square is a triangular wave. Okay, we can see the V out formula. This is a very important. It means it indicating that it's a minus 1 of R1 CF integrated V in into dtt plus c. And the frequency response of this basic integrator is, that is, f is equals to 1 divided by 1 divided by 2f r1 into cf. And one main important thing is, in fact, the input signal will be integrated properly if the time period t of the signal is larger than or equal to rf cf. That is, t should be, that is a time period, the time period should be greater than or equal to the product of this rf and the cf. Next one is the differentiating circuit. The differentiator performs the reverse of the integrator's functions. Okay, it's exactly opposite or a reverse of the integrator. So as its name implies, the circuit performs the mathematical operation of a differentiation. That is, the output waveform is the derivative of the input waveform. Okay, that is, if we supply the cosine sign at the input, the output is a sine. So if we supply the triangular wave, it will give the square wave. So the output the output formula of this differentiator is a V out is equals to minus RC derivative of the V in. So next, the frequency response of this differentiating circuit is 1 divided by RF C1 and in 2F, the frequency response of this is 1 divided by 2F 2 pi R1 C1. And the input signal will be differentiated properly. To differentiate it properly, if the time period t of an input signal is larger than or equal to RF CF, that is, the time period t should be greater than or equal to the RF, the product of the RF and the CF. Comparator circuit. It's also a very important application of an op-amp. It means it will compare the signals. Here in this case, we are taken the one voltage as a reference voltage. We can pass this reference voltage at the inverting or the non-inverting, and at another end we will supply the voltages which we need to measure, where it is higher than reference voltage or whether it is lesser than the reference voltage. So it will compare the voltage and give the output at the V out or at the V out terminal. So now the analog to digital converters. An electronic integrated circuit which transforms a signal from analog to digital form. In this, because in the digital form, we need the signals at the output, those should be in the digital form, like 0 1 form. So for that we use the amplifier to convert this AC into DC, or it's analog to digital form. So some examples of this ADC usage are digital voltmeters, cell phone, thermocouples and digital oscilloscope. This is how ADC works. Mainly there are two steps for analog to digital conversion. There is a sampling and holding, or quantizing and the encoding. The ADC process is shown in the figure below. Okay. Next, sampling and the holding. It's used to sample the given input signal and to hold the sampled value. Once the signal is sampled, it is called as a discrete signal. Okay, the holding period may be from a few milliseconds to several seconds. Means the signals are here sampling and holding. Sampling at the time of a sampling, it is a high voltage, At the stage of a holding, it's a 0 volt. Now it's a quantization and the encoding. Quantization is a process of rounding off a sampled value according to some rule. Okay, suppose we can see the examples here. If it is a 3.7, means after the decimal point, if it is a more than 5 or equal to the 5, the digit will be a round off as the 3.8. Okay, so encoding means after identifying the closest value, a numerical value is assigned to it and it is encoded in the form of a binary numbers. Thank you all.